Good afternoon, everybody. Thank you for joining us. My name is Eliza on behalf of Pandell. We're delighted to see everybody online with us today. This is the next in our Pandell Leadership Series of webinars, and we're talking about location intelligence strategy for the pipeline industry. So today we're delighted to have Jeff Allen with us as our speaker. Jeff Allen is the Global Pipeline Practice Lead at Esri, and for the past 25 years, he has been helping operators in the pipeline industry utilize location enablement technology to manage the overall life cycle of their assets. Jeff is also tasked with improving and understanding the pipeline market, its customers, and portfolio. He provides industry expertise and engages with key pipeline accounts globally. Jeff holds a Bachelor's of Science in the Survey Engineering from the University of Maine and has also led a successful Esri business partner organization in the pipeline space. So we are very lucky to have Jeff with us today. And Jeff, I will hand the floor to you.
Thank you for that wonderful introduction. I really appreciate the time everybody spent with us today and listening into what we're talking about in the pipeline industry. It's sometimes, some days it just doesn't feel like a job. It's kind of my passion and really what I love to talk about. And Esri gives me this wonderful platform to really work with operators across the globe to talk about what their challenges are and how they can kind of leverage geospatial technology within their organizations. And as we talk to these folks, one of the things that we increasingly see as a need within these organizations is, we're still going through some form of digital transformation. And this has been ongoing for years. We moved from paper maps to AutoCAD to digital GIS, and now kind of really seeing the proliferation of these GIS systems as a tier one system in these organizations. And with that really comes a need to pour more information into these systems, right? They first started out as automated mapping and facilities management, really kind of a mapping tool. But now we see more and more organizations or more groups within these organizations needing to tap into this rich location information and rich information about the pipeline assets to really make more informed decisions about their operations. And with that comes a series of challenges as we continue to grow these systems within these organizations. Now, oftentimes when I'm talking to an energy company, they might have lots of use cases across their portfolio. They might have upstream assets for exploration and production, downstream assets. We often see companies now getting into the renewable space as well. But today I really want to kind of focus on this midstream space. And this traditionally has been an area where we've had a lot of different interest around geospatial technology, a lot of it driven by regulatory requirements. But even now beyond that, we see a lot of different use cases for how we leverage location intelligence within a pipeline organization. And if I kind of open up that pipeline box and take a look inside, these are some of the typical use cases or typical departments within an organization that they might be using or leveraging this geospatial technology. And regardless of who we talk to or where we go, we always find this sort of asset management or mapping department. They're really the ones that are responsible for building out the data sets. This is usually where the GIS professionals sit. And they're responsible for the care and feeding of this location model and all the different attributes that describe the pipelines and the devices and the characteristics along there. Now, one of the things that we're really interested in this group is a notion of TVC, traceable, verifiable, complete. It's no longer appropriate just to put points and lines on a map. We want to really know where this data came from, what that witness of installation document is. Maybe it's an as-built, maybe it's a strength test report, or maybe it's an MTR from the mill. That's what that asset management group is really responsible for, is pulling all that information together and putting it into that central repository. Now, once we find that group, often what we'll find just next door is some group really charged with compliance and integrity. And this tends to be the largest consumers of that data. And we often say, if we did nothing with this GIS data, it really drives these regulatory compliance activities. And in a sense, to be able to meet all these regulatory requirements, you almost have to have a GIS these days to be able to do some of the calculations that we perform against that data. It has far-reaching opportunities beyond that, but these are kind of the core pillars that we see in most organizations that are leveraging some type of location intelligence. Now, once we have pipeline integrity kind of under control, we often see the need to take that data and now share it with the people in the field doing the actual operations, right? And this is really twofold. The operations folks need to know what's in the ground, where it's located, what its characteristics are. But more importantly, they are capturing data about ongoing operations that we want to feed back into that pipeline integrity process. So it becomes a bit of a feedback loop. We send digital information to the field and receive digital information back from the field that goes back into those back-end processes. Now, if we have those people satisfied within the organization, then we look for more opportunities. And one of those opportunities actually might be in the asset development, the planning and construction, building and as-building of new pipelines. This could be 100 miles or it could be 100 feet. We want to be able to take that information as it's captured in the field, kind of think of this as the as-building process, and be able to easily load that back into the asset management system so that we can seamlessly share that with operations. Wouldn't it be nice when the pipeline is finally as-built and product is flowing, that operations had the real-time view of that in their field and mobile applications, right? And that's where a lot of the focus is these days, is really getting this workflow and this sharing of data across the enterprise. And that's really where one of the places that Esri really shines is sharing and collaboration, building data sets, and then moving out to the people. We often say we share data with anywhere, any place, at any time using the Esri platform. Now, there's plenty of other opportunities within the business to leverage geospatial. Health and safety has a huge number of opportunities to really perform and automate some of those processes, as well as the back-end business running of the business, as well as then sharing that information with people who may be outside the organization. We're using a lot of the new web technologies to share information with external shareholders. Maybe they're contractors, maybe they're regulatory agencies, or they may be the one call center that's responding to tickets, incoming dig tickets along the pipeline. All these people play together. And really one of the real sort of challenges here is we all want to be pulling this data from a central source of the truth. We really don't want to have separate business systems that have the opportunity to be misaligned, right? If we can all share this off of the same source and then feed that out to these different shareholders, then we can really gain some efficiencies within the organization. So how do we do that? Well, one of the other challenges we have in pipelines is that pipes are in lots of different locations, right? We have our traditional midstream pipelines, the large diameter hazardous liquid and gas transmission pipelines. We also have to service the upstream space as well as the downstream supply chain as well. And one of the challenges that we've seen with geospatial technology in the past is companies have had to build sort of separate individual GIS systems based on where they are in the supply chain. The modeling techniques and the requirements of upstream are very different from what we do in midstream and completely different from what we do in downstream. So one of the things we've been doing with this location intelligence system is be able to build a single source of the truth that really spans these different parts of the supply chain. We can use a simple set of, or single set of tools and a single set of processes, regardless of where the pipe is in the supply chain. This is one of the big drivers for what Esri's been doing with our technology, because most of our larger companies have come to Esri and said, hey, we really need to do more with the same amount of people in our organization. So we need to streamline some of these processes and sort of reduce some of the complexities in the IT. Now, if we really look at the business needs, separate this from the technology for a second, we sort of also see these common patterns forming across these organizations. As I mentioned, complete, accurate, and current data. Almost nobody can argue with that. It's the fundamental building block of these systems. We need to move information in and out of the field, and we need to be able to collaborate across the departments, right? But then beyond that, what are the other business needs that we tend to see as common across these different organizations? We want to provide a comprehensive view of operations. What does this mean? It means taking these maps and making them come alive with data. Oftentimes that means bringing in some form of SCADA data into the maps, but it could also be real-time weather, real-time locations of workers in the field, and how all that data that's changing over time interacts together. I often refer to this as making the maps come alive. Now, a GIS can't live on an island on its own. It has to integrate with other business units. Maybe we have Maximo, but we have SAP. We need to be able to share data that might live in these other tier one business units and make that all seamlessly work together with the location information we store in GIS. Again, ultimately, we'd like one system of record for our GIS, not have to have these silos of data. And one of the other things that we see in pipelines that's very interesting is oftentimes the work we do in pipeline might span multiple days, multiple weeks, and we need to be able to track that all the things that we're required to do get accomplished in the time frame. So if we were to open up our operations manual and say, hey, if we did this relocation of a pipeline, here are all the internal stakeholders that are impacted, and these are all the things that they need to do. We want to be able to prove that all those things actually happen, and we do that through workflows built within the system. Now, if you've been around Esri for any number of years, you know we have a lot of things in our toolbox. I often call it the ArcGIS alphabet soup. And so how do we boil down the ocean to make it easier for folks to understand how spatial analytics and location analytics works within their organization? And oftentimes I will turn to this pattern of use slide. And basically what this explains is like, if you have a business problem and we can identify the patterns of use for geospatial technology, we can then figure out what underlying technology is required to bring this all together. And so what we'll do in this case, maybe we have an ILI program for pipeline inspection. We need to develop some type of tooling and data sharing and governance around this. What will we do? Well, we most likely need mapping and visualization. We probably need some form of analytics, decision support, and planning. If we could put the uses and patterns of use together for a single problem that we're trying to solve, we can then link to the underlying technology that we need to implement to get this project done. Now, oftentimes we'll put these together in larger groupings. So mapping and visualization and data management really goes to what we call the system of record, that single source of the truth. Decision support, planning, and collaboration is a system of engagement. How do we get that data out to the people who aren't GIS professionals that need to be able to consume this information and make decisions? And really the system of insights is all about those analytics. Sure, I can map things and I can share it, but people need to be able to run analytics and get information out of the system to help them make more smarter decisions about the operations. So this is how these kind of big building blocks come together as you're implementing a geospatial technology within your organization. So often when I talk about this in a sort of large vision, people often say, okay, well, where do I start? How do I start in this journey? I might have some GIS technology. It might be in its infancy, or maybe it's very robust and complex. But how do I start with expanding this so I can really hit on all those key factors that we have in a system of record, system of engagement, and analytics? And I often say it really does start with the GIS professionals, right? These are the folks that are really charged with building these data sets and maintaining this data over time and running these spatial analytics. And for us, that means a tool called ArcGIS Pro. And this ArcGIS Pro product has been around for a number of years now. You might know it as its predecessor, ArcGIS Desktop. ArcGIS Desktop was actually 3 separate applications: ArcMap, ArcGIS Catalog, and our 3D viewer. And now with our implementation of ArcGIS Pro, this all comes together in a single application, really built on the modern technology and wired into the rest of our platform to make that data, once it's built, easily accessible and easily shareable with the rest of the organization. And really, we've done a lot of work to now bring all this new technology, making sure that we have moved over all the legacy functions from our desktop tools into ArcGIS Pro. And now everything we're doing here at Esri really is around this Pro platform. If you have GIS in the organization and you haven't made that jump to Pro, now is really the time. We're at equivalency with the legacy products, and we continue to build more and more tools in the Pro platform. And this really brings me back to the pipeline story. So if you were to go back even 5 years ago, and you were putting in a pipeline data management system within your organization, you would most likely come to Esri to buy a desktop tool and a server. It was a very transactional approach. And then you would go into the marketplace, into the other Esri partners, and buy the rest of the tooling that you need to manage that pipeline data. And Esri is actually now implemented in this ArcGIS Pro platform 2 tools, specifically pipeline. One is called ArcGIS Pipeline Referencing. This takes care of that midstream space. We typically use linear referencing to model the pipelines. And here we've implemented tools to do route management, support different measurement systems along those pipelines, make all that data time aware, and build you a flexible information model that allows you to implement these tools within your larger pipeline asset database, right? So we support most of the major pipeline data models out there, and we have a sort of a core that you would implement to turn on linear referencing within the ArcGIS platform. The other important part of this, and really across the board, is as we move kind of more into the digital twin space, full support for 3D. So if I have vertical piping and I need to have measures going in the Z direction, I can now manage and model that within the platform using the ArcGIS pipeline referencing tools. Now, the other tool that we've developed specifically for Pro that does lend to this story as well is where linear referencing is really good for dense data sets along those pipeline networks. One thing it lacks is you'll be able to connect pipes together in a network. So here what we do is bring in the ArcGIS utility network to the puzzle, where we can create a connected set of pipes that work side by side with that linear reference data. And when we do that, we now turn on some additional capabilities as well. We can build single line schematics or diagrams from that data. And as the data gets really complex, sometimes it's not really appropriate to represent something on the screen as a single point or a single polygon. Here we've introduced the concept of containers or component views, where I can have an object that contains other objects within it. So I might have a launch receiver assembly or a mainline valve. It's represented a point or a polygon on the map, but inside of that are individual pipes and elbows and T's and fittings, all that describe what makes that component. So I can really get down to the individual details that we need to run some of these analytics on the back end. And here again, we support full 3D, this idea of time, right? Historical and plan views. So I can go backwards and forwards in time in this data and see how the pipeline has changed, and then make decisions based on that information. Now, how does this come together in a single enterprise system? Well, what we do is we build a single enterprise geodatabase underneath. And depending on what type of data management I need to do, whether it be linear referencing or connected pipes, I then use these pipeline referencing utility network tools in combination. And what this allows me to do is to really manage from the wellhead to the meter tip and all those pipes in between. Single system of record, single set of tools, manage that entire supply chain. Now, if you're in the pipeline industry and you've been working in pipeline GIS for a number of years, you've heard about things like the Pipeline Open Data Standard, PODS, or Esri's template data model called UPDM. So the 2 tools that I just talked about, pipeline referencing and utility network, actually work within these data models. So we often say that the Esri tools are pipeline data model agnostic. You can even put these core schemas into your own data model and turn on this functionality. So now PODS and UPDM have the ability to do both linear reference pipes and connected pipes or network of pipes within these central data models. That's really important because you don't necessarily have to choose which data model you need based on the capabilities. You choose a data model based on what best fits your business. And we can then use our tools with whatever that choice is. Now here's an example of a traditional linear reference network, the red lines, large diameter transmission lines bringing, in this case, product into a tank farm. Now with linear referencing only, maybe I would just represent that facility at the end of that pipeline segment as a simple point or a simple polygon. But now with that advent of building in that connected set of pipes, I can go inside that station. Like I can come off the linear referencing system and build this network of pipes inside this facility, which was very difficult to do with just linear referencing alone. You'd have to create routes and calibration points where they didn't really exist. Here, I can just do simple mapping and create a connected set of pipes in that facility. But if I want to go in even deeper, say to this pump station, which might be represented as a single point or a polygon on the map, here's where I can use that container. I can open up that container and start mapping out the details inside this facility. Now, oftentimes this data exists within the organization, but maybe it's locked away in CAD drawings, or maybe it's locked away in paper maps. Now we can bring all that detail onto the GIS and make it accessible for a single point for everybody within the organization. Now, one of the advantages of a connected set of pipes is the ability to do what we call trace analysis. Now that my pipes are connected, I can start asking it different questions. For example, where are my isolation zones? If I needed to isolate a part of the pipeline, where are the closest valves that I need to shut? Or things like pressure zones, right? We're giving the system the ability to understand where pressure changes along the line. And in this case, I could then query the system and say, hey, show me all the devices and fittings and pipes that see the same pressure coming out of this pump or compressor station. Maybe that feeds into some type of downstream modeling system or MAOP calculation, right? That's some of the benefits I get of these connected systems. And it doesn't really stop there at the pressure or the product in the pipeline. We can also now model the cathodic protection. So show me everything on this pipeline that's electrically connected together. So maybe my mainline valve, right, is non-insulated. So the CP runs through there, but I can shut the pressure off at that location. Or I have an insulated flange. I can't control the movement of product, but that insulation between that flange stops my CP. So now I can create CP systems that I can feed into my other programs that you require that type of data. So all kinds of ways that we can use this new network of pipes to really turn on additional functionality within the platform. Now here's an example of that same tank farm. I'm just showing it in a schematic view. So you can think of this from an operations perspective. I have this sort of spider web of pipelines that are running over that facility. If I was operating this area, maybe this view of the facilities tied to the mapping would give me a better sense of how the system is working within this facility. Think of these almost like subway maps, right? And I can represent these in different ways, but the key here is these maps are being driven from the GIS. If I make a change in the GIS, it's reflected in the schematic. If I click on an object in the schematic, I can bring through details, or I can navigate to that location on the map. There's meant to be a two-way interoperability between these diagrams and what we have in the mapping system. Now, one of the real challenges we've had in building out these systems is really understanding the intersection between GIS and CAD, or intersection between what we call capital portfolio management, the ongoing maintenance and management of the pipeline, and how we do design and building of new pipelines. And so I've sort of built this diagram to kind of show how that relationship goes, because as existing assets are in the ground, we're really in that capital portfolio management, right? This is the maintaining and the operations planning of those existing facilities. Now, as I want to expand my system, I might then move into a design phase. Well, would it be nice, instead of the CAD folks starting with a blank piece of paper, if I could take everything I have in my GIS system and share it with my designers? So that's one of the things we've been working on here at Esri, is how to share that information out to the non-GIS platform, maybe the CAD platform, use as the basis of design. Now, I would never recommend that somebody design a facility in GIS. That really is the 3D design space of the CAD world. That becomes an as-built, and that as-built documentation, whether it be 2D maps or 3D BIM files, is what we want to bring back to that capital portfolio management. That's that loading of the as-built data that we need for operations. And we've really struck this synergy between the GIS and CAD world about sharing data and then easily loading that data back in, whether it comes from a third-party contractor, it comes from your in-house designers. We want to make that flow of information as seamless as possible so that we're not having to re-enter or reload data as soon as the project's complete. We can put it right into the system. Now, the other thing that's really important about this is as we start integrating with other systems within the organization, we really need to do a plan for what we call master data management, right? So let's take, for example, I have my asset management system and I also have a work order management system. Well, maybe both systems have this valve and both systems name the valve the exact same way. That's great. We can use that unique identifier to then link those systems together. But without some type of plan, that never just happens by default. Maybe GIS calls this valve 168B and work order management calls it -1. Really makes it hard for us to link those systems together. Or worse, GIS doesn't have this little bypass valve, but it's something that we need to operate and spec, so it's in the work order management system. Often cases, both systems are missing the information. So without a master data management plan in place, which is less technology and more process driven, we need to be able to set up these systems so that when a new asset is added to the system, we link it properly for all the tier one systems and allow them to share the information back and forth across the organization. So we help customers figure out this master data management plan and then put that plan in place. Now, Esri doesn't do this as an island, right? So I've been talking a lot about the Esri technology, but we bring partners to the table as well to help build out these large systems. Really what Esri wants to focus on is the management of the pipeline data. That's using the pipeline referencing utility network tool in our templates. And we want to help share that data across the organization through mobile applications, web applications, and our portal technology. Where our partners come into play is building all these SME tools and all the other stuff that surrounds these systems, integrating with data, bringing new data sets in, the domain expertise. This is key in how we play together in this space. Now, most organizations find themselves on a geospatial growth path. Very rarely did GIS start as an enterprise system. It often started as a department implementation. I often tell people nobody ever bought SAP for department. They came into the world as an enterprise system. GIS and geospatial technology kind of built up from the department level up. So often we'll see this sort of initial implementations in, say, the mapping or engineering or integrity department. But often what we find is this organic growth. Right? As people start to tap into this data, see the power of it, we tend to see champions and evangelists come alive that really go around the organization and say, wow, you really need to see what we can do with this GIS information. And there's this sort of uptick in organic growth and more people want to tie in and take advantage of it. And that tends to lead to a second larger implementation that really takes across, multiple departments and what their individual missions are and starts to plug this together. And then all of a sudden we see this kind of community of excellence start to evolve, right? Cross departmental sharing information and really this groundswell of interest. This is really where things get interesting because then the GIS manager finds a line outside of his door with 3 or 4 different departments saying, hey, we've seen what these folks can do. We want to be able to do the same thing with our data, right? And that leads to another set of problems is, hey, we really need to then set a strategy for that growth, right? We can no longer just do the squeaky wheel mentality of who shows up first and we'll do that project. We need to figure out, okay, what is the larger enterprise strategy for geospatial? And how do we then start to prioritize these programs so that we get the biggest bang for our buck for our investment? And how do we do that? How do we build that foundation and take customers on that journey? Where it really kind of comes down to a strategy, or in effect, what we call a geospatial strategy. And why do you build that geospatial strategy? Anybody that's been involved in any type of GIS project or GIS implementation within a pipeline organization will really kind of grab on to some of these words on the screen. You know, we have data silos, we've missed opportunities, we have digital transformation initiatives going on, we have IT support issues, right? All this stuff are challenges that we need to overcome as we build this geospatial strategy. And so one of the things we do is we go back to those patterns of use that I showed earlier. And I take all the different stakeholders that I have in my organization and I start mapping out, do they have just a need? Do they have a foundational use, or are they advanced users? This starts to lay out the framework of how geospatial strategy is currently being used in the organization, right? Where those evangelists live, and where are the opportunities that we can leverage in the new organization. Once we understand where the opportunities are, then we really want to look at prioritization. Because what we want to do is we want to find the quick wins, so those things that are easy to do and have high business values, or maybe a little harder to do, but still have high business values. We want to focus on those first. What we want to do is we want to avoid those really hard projects that only impact a few individuals in the organization, right? That's not going to give us the biggest bang for the buck. So we focus on the quick wins. We plan for those high values. And as we get those projects under control, then we can look at maybe some of the lower value, but still easy to do, and knock out those. So that's how we kind of prioritize a geospatial strategy for organizations, so they have a roadmap and they're not just taking the next project that shows up on their doorstep and implementing it. And that brings us to our kind of last topic of our talk today, which is, these GIS systems tend to now become seen as a foundation for digital twin initiatives. Digital twins are becoming a very popular buzzword in our industry. We have lots of organizations then positioning themselves as digital twins. We at Esri feel that we've been doing some semblance of digital twins for a number of years now. And really, what is this idea of a digital twin? Because when I first had it, I sort of had this vision in my mind what it was, but I didn't really understand how GIS maybe played with that, right? So if we go back to the definition of what a digital twin is, it's that idea of the physical assets themselves, how they work together, and the relationships and behaviors between them. Now, we think that GIS creates this foundation to build this, not only of the built environment, not only the pipeline assets, but of the natural environment as well. And it's the interplay between those two that we think makes GIS in the digital twin space really, really unique. And there's all kinds of leading use cases around digital twins: performance prediction, training, optimization, integrity management, right? If you're looking for use cases for digital twin, if you're looking for business values, there's lots of them out there. Now, one of the big challenges, and this was my aha moment for the digital twins, is how does that fit within the Esri ecosystem? And from an Esri perspective, this is how we look at it. The pipeline data management system forms that historical baseline or system of record. Then we pull in that operational performance, the real-time data. And then we take those two things and we create algorithms that allow us to do future prediction, right? I want to take the digital twin and ask it questions and see what the twin will react in the future. So maybe, for example, I have a system that has a number of pipelines that supply a number of different areas around the country, and I'm able to load in all my historical weather data and all my historical flow data. And let's say there's a storm coming next week in the upper Midwest. Wouldn't it be cool if I could go to the digital twin and say, hey, if I have this type of weather event coming next week, can you then predict what the demand on the system is going to be? And maybe I can line pack ahead of that demand. And we've seen organizations build these type of algorithms to help them future predict. And in this case, then extend the life of the steel by not putting that immediate demand on it next week when that weather event occurs. Now, this is just one example. There's literally hundreds out there, but that's really the idea you want to get your head wrapped around for this digital twin is it's the model, the physical assets, the real-time data, and then the ability to test future outcomes against that model. Now, the other thing that makes this really important, and I think the thing I want to leave with everybody today, is it's all about location. Location matters. Location is what allows us to pull all this information together into a single kind of seamless system. I often tell customers that, location is the ultimate foreign key. If you can tell me where two things exist spatially, I can tell you how they interact together, and I can unlock the potential of that information beyond what I could ever do if I had spreadsheets and databases and separate silos of data within my organization. So geospatial is way more than just seeing points and lines on a map. It helps us bind this information together and make smarter decisions for the organization. Thank you for tuning in today. Really appreciate all the time this afternoon. And I think at this point, we'll open it up to some questions.
Great. Thank you so much, Jeff. That was wonderful. Here's a good one. How would an organization get started leveraging GIS within their organization, assuming they don't currently use it?
Yeah, so that's a great question and one we get all the time. We have a number of different templates or solution templates on the Esri website that we actually give away free to our customers. There's actually a pipeline page there that you can go in and you can download some free templates that really are starting points on this journey. But really, it's all about data, right? Where does that data live within the organization? Is it a bunch of points coming from a survey? Is it some historical maps? Oftentimes we see just lots of KMZ files and shape files within the organization. It's really about organizing that data into a central repository, getting it all aligned, and then being able to share it out with the organization. And that might start as just a simple facilities map. And oftentimes that's where it does start. And then once you get that groundswell, once people start seeing this information, they say, hey, can you do this? Hey, what about that? And it's those ideas from the organization that allow you to sort of drive that system forward. And this is where it's really important. Like we have a number of different events throughout the year where we have users come together and tell their stories. Because I've had more than one customer sit in the audience, see a presentation and go, oh, that gives me an idea. Go back home and implement that and be super successful. So there's a huge amount of knowledge sharing that goes on within our industry to help people wherever they are in that journey, that geospatial journey.
Great. Thank you. And with regards to online materials, can you just direct people maybe to either the ones you just referenced or additional learning opportunities on the same topic?
Yeah, there's a couple. And actually, I've been curating an Esri pipeline channel on LinkedIn where I've been posting a ton of information. So if you haven't linked in with me, please do, and I can redirect you there. If you just Google Esri pipeline events, you'll see a kind of a calendar of all the things that we've gone up for live in person and also webinars. And then if you also Google the Esri solutions page. And what I'll do is I'll add some links to the presentation when we send it out. So people, if you're not able to find it, I'll have those direct links on the last page of the presentation.
That will be incredibly helpful. Thank you, Jeff. For companies that do not use PODS pods or PDMS, what format or databases do you suggest?
Yeah, so it really starts with points, lines, and polygons, right? So the UPDM model or the POS model are really just great resources that people have come together and said, hey, instead of starting with a blank piece of paper, here's all the things we think you should have for a valve or a pipe or a casing or fitting, right? So you can use them as guides. But ultimately, every organization takes their own journey of how they set up those data models. Some use pods and UPDM off the shelf, no other modifications. But more often than not, they use it as a starting point and then add all the different details that they need that are specific to their organization to these data models. But in the end of the day, we're modeling, geospatial features on the map and then adding all these business attributes to describe those features, and then turn on that functionality that I was explaining during the presentation.
So thank you for your time today, Jeff. It was really a pleasure having you join us. And thank you to everyone who joined us online. And great to have you, and have a wonderful afternoon.
Fantastic. Thank you for the opportunity. Thanks everyone for joining in.